Hello, everybody, and welcome to this tutorial on structured query language SQL. Some of you may be slightly familiar with the topic, some of you may not, but today we're going to take a quick look and with practical examples on how to do this. My name is Mohamed Hussein, and it's my pleasure to take you through this portion. So what is SQL? What does structured query language mean? I'm sure each one of these words individually means something to you, but collectively, what does that mean? So it is a standard language for retrieving and manipulating databases. So if you think about many of the products that might be running in your hospital or other environments, there's usually a database behind to store the information. So just like for medical imaging, we have standards like DICOM and HL7. For databases, there's a standard called SQL, and it is the standard for being able to read the data from the database as well as write to that data from the database. However, just like DICOM and HL7, the standard is not 100% strong. So there are some slight variations, and we'll talk about that in more details later. So all the big database vendors out there, like Oracle, Microsoft, and the open source ones like Postgres and MySQL, they all support it. There are many other database flavors that also support SQL. It's a very well implemented standard, again, with some nuances. As I said, some of them will have slightly different dialects of SQL, but at the end of the day, there's something called ANSI SQL, which is the global standard. That's the core set of the standard that's supported by everybody. And then there's the variations of the dialects. So there's, Postgres SQL or Microsoft SQL that has extra bits and pieces they've added specific that are proprietary to their format. Usually, these are for performance optimizations because every database engine or product is a little different. So some of these variations take advantage of their proprietary performance optimizations. And of course, it goes without saying that just because SQL is standard doesn't necessarily mean that the structure of how the data is stored is standard. In the example we're going to walk through today, you're going to see that my database has a table for study that stores the actual studies, and the table for a series that stores the series within a study. The one product I used, which is open source, uses this format, but not necessarily all products use that. In fact, the product I use in this presentation is DCM for Chi, the old one, not the new one. Whereas I know other products, for example, like Orthanc, use a totally different database structure that's a lot harder actually to read. Of course, you can't talk about SQL without talking about the elephant in the room, which is NoSQL. So NoSQL is a totally different beast than SQL engines. However, some of those NoSQL engines do support the SQL language for being able to retrieve data. But the difference is too technical for us to cover today, so I'm just going to leave it. But it's just important to know there's a difference between these relational databases, like the examples I gave above, and NoSQL. They're very different. So what is the advantage of using SQL for accessing the data? A lot of times, you're able to get at your data through the front door APIs, so to speak, something like HL7 or DICOM. However, sometimes these APIs are not ideal for being able to get information. For example, if you wanted to find a cohort of patients, trying to do that through a HL7 version 2 feed is akin to suicide, because now you got to listen to every single message flying in, and variety of messages and variety of machines is just not really very realistic. If you wanted to retrieve a cohort of patients via DICOM DIMSI, that also may not be the easiest task. Even though you can do it on demand, it still is a lot of back and forth, and you're going to run into nuances with concurrency and bandwidth and things like that. So a lot of times, SQL is a backdoor that allows you easier access to your data. So you want to round up a list of patients or studies between certain dates, it can just run a query and you'd be able to get that information super easily, super quickly. Now, keep in mind, just because database is an option doesn't necessarily mean it's the one to use every time, because there will be cases when you have information that's not stored in the DICOM. Just as a random example, imagine if you're trying to retrieve some private DICOM attributes. these are very unlikely to be stored in the database. Usually the database will store most basic information about every object in the hierarchy. So for a patient, it would be things like patient name, date of birth, gender, the multiple identifiers a patient may have. For a study, it would be things like study date, study time, et cetera, et cetera. But again, when you get to specialized attributes, you're probably not going to find those in the database. And again, the type of database engine or product and the structure of the database, sometimes also called the schema, will vary by vendor. So different PACS vendors, different EMRs will have different variety. The nice thing about SQL, though, at the end of the day, is that it's well supported, as I said, standard between the database engines, but also you have multiple choices for graphical user interfaces that you can use, as well as being able to write scripts against a SQL database in a variety of programming languages. And both here, like we're talking serious programming languages as well as scripting. So what are we going to do today? As I said, I've got an example database from DCM for Chi. So this is the version 2, the old one, and it's running against MySQL. So we're going to play around with that database and see what it would look like. The client I'm going to use today is a web-based one, not something you have to install on. You don't install it on a machine, on your workstation. You install it on a server and you use it through the server. So the one I'm using is called PHP MyAdmin. And it's just, it's a freeware, but the easiest one to use for today. And then we're going to have a look at the database structure. So the hierarchy, I picked DCM for Chi for this reason, because the hierarchy they use is very nice and easy to use. It goes patient, study, series, instance. So very similar to the DICOM hierarchy, which should be very familiar to people on this call. So let's start with something really simple. Let's just ask for the list of all studies. Now, as you can see, you do not want to try this on a real system with a lot of studies, because this could bring the system down. The one thing with SQL is it can be very powerful, but it can also be powerful enough for you to shoot yourself in the foot. And you want to definitely avoid doing that. That's not a great idea. So in this case, I'm saying, give me all the studies in the system, because in my case, my system has a handful of studies. Not too many. So I know in advance what the result looks like. I'm just showing you a super simple example. You'll also notice throughout my slides that I'm highlighting SQL vocabulary. So that's the vocabulary you use here. Select star from study. So the select in this case means these are the columns I want. Star, columns or attributes, depending on which word you prefer. Star means all of them, just return everything. I don't want to have to bother naming them individually. From is where the data is coming from, and in this case, it's the study table. So let me get my query copied and pasted here, and we're going to run it into. So let's go to PHP MyAdmin. So what I'm going to do is I'm going to click on the SQL tab over here. There is the interface here. So usually when you load it, first when you log in, you may come in and you see the database over here. It's got the tables listed on the left. They're also listed here on the right with additional actions. I don't need to go through any of this right now. I don't need to bother you with the details. So I'm just going to go ahead and click on SQL. This allows me to put a query in, and I've already copied it. So I'm just going to paste it, select star from study. As you can see, I'll zoom in, just make sure this is more visible. So then now I'm going to click go. And as you can see, this is now returning the results. So again, this is a structure from DCM for Chi version 2. This may not necessarily apply to your PACS vendor or EMR vendor, but it's just to demonstrate the point. So you can see here, there's something called patient FK. FK is foreign key. And that basically is essentially a pointer that points back to the patient record, which is in the patient table. In a minute, I'll show you what it would look like if I clicked on this. And then if I scroll to the right, you're going to see some information about the study. So there's the instance UID. There's a date and time, there's a accession number, and potential information like referring physician and stuff like that, which I haven't actually bothered because these are anonymized studies. There's a study description, and then you can see there's more information about this. If I click on the patient foreign key here as an example, so if I click that through, you'll see that that actually takes me to the patient. and there's information about the patient. This is the patient table. So there's a patient ID, and the patient name is SimAndy, and there's suffix there, and so on and so forth. Okay. Alrighty. So going back, let's spice it up a little bit. So let's say I don't want all the columns to be returned because it's too much for me to read. And as you saw, a bunch of them are empty anyway, so they're not super helpful. So let's try and get a little picky with selecting which columns we want to see. So here I'm saying select accession number, study date time, study description, mods in study is modalities in study. That's the DCM4 wording for it. The number of series within that study, and then the number of instances from study. Now, you notice this is still a query in the danger territory because this query doesn't have any constraints. I'm not saying give me specific list of studies or studies between two specific dates. I'm just saying give me all the studies, but I'm just refining the attributes that I'm receiving. So you see here, I went again to my SQL tab. I copied and pasted the query, and then I'm going to go ahead and click go. So now the result is a much more comprehensible result. As you can see, I've got the accession number, study date, time, description, modalities in study, and the number of series, number of instances as well. So that just compressed it as far as what the data is returned. Now, what happens if we take this one step further? And let's try and constrain this query, okay? So this is the last one that you cannot run on a production system, I promise. After this, you could try the other ones. The reason why is, as you can see, it's the same query. What I've added now is I've added a where clause. So the where clause in SQL is where you can constrain something to any number of conditions that you want to create. So in this case, the conditions are relatively simple. What I'm saying is, I want study time that is greater than January 1st, 1990, and less than June 17th, 2019. Don't ask me why I picked that date. It's arbitrary. So the reason I say don't run this on production is because in your case, this is going to return pretty much every study in your system up until that date in 2019. So it's not a great idea, but in my case, it's just for demonstration purpose. So I've got this query copied, and I'm going to go ahead and switch back here. So I'm going to, once again, click on SQL to run a SQL, and I'll replace this with MySQL. So again, same SQL as before, just added the constraint. Now, in my case, all the studies I have in my system are within that date range. So the return result is actually going to look the same. It's not really going to be any different. Just for fun, I could probably modify it. So you see here, there's a cutoff. There are some from 2000, and there are some from 2008. So if I go back to that SQL one more time, and I'm going to make the date here 2007 as an example, and I expect the results will be cut in half. And indeed, that's what you see here. The results were cut in half. So I'm only getting studies from the 2000s. Okay. So one cool thing about SQL too is if you are running a query that you are expecting to return a lot of rows, you also have an option of saying, don't return everything, just return the first 100 or the first 10 or the first 1,000 as an example, which is really helpful, especially when you're exploring table structure. You just want to kind of see what data is in that table. You just want to familiarize yourself. Like, give me something visual I can go by, and then I'll start refining. So here, what I've done is I've done two things. You'll notice I've added an order by clause. So this is how you pick your order. So I'm saying order by date time. Desk is short for descending. And I should have highlighted this here. I apologize, I forgot. So descending means the newer date is going to be on top, and the older dates are going to be at the bottom. If I don't have that keyword, then it will by default go from lower to higher. So if I remove the descending keyword, then it will be the oldest date to the newer date. And then you notice the next thing I said is limit 100. In this case, limit 100 is going to return the first 100 rows. Now, as you recall, my database does not actually have all that many records. So again, this will not look very different except for the ordering. So you notice that the studies that are from 2008 are now on top versus the ones from 2000. Okay. Now, what if I change this limit to, let's say, 2? Okay, so limit 2, and I click go. You see now this is returning only 2 studies. So that's how you use a SQL limit. Again, the thing with limit is that it's not necessarily universal. Most database engines implement it, but some of them don't. So for example, Microsoft SQL implements a top keyword. I'm not actually going to explore that now because I don't have that handy. But if you're using a product that has a Microsoft SQL backend, I encourage you to look into it. Okay. Now, what happens if I want to combine data from multiple sources? What happens if I want to be able to get some study information as well as some series information? Well, that's where you enter a join, a SQL join. So that says bring these 2 tables and mush them together to bring me back results. Okay. So what you'll notice here is I'm saying from study and I'm saying as ST. So I'm giving it an alias just so I don't have to keep writing study, study, study. I'm just saying ST. I'm going to join it on series. So bring these 2 together. And I'm joining on the condition of that series belonging to that study. That's basically what I'm saying. So I'm not just saying give me any random series and mush it with any random study. I'm saying I want the series that correspond to this particular study. Okay. Now, if you look at the columns here, you notice I've got a prefix on the column. So I've got st.accession number. So that's meaning it's from the study table. Okay. And then over there, you notice towards the end, I'm asking for series information. So SE is the alias that I give the series table. And I said series description and body part. So that's what I'm looking for. I'm looking for the series description. I'm looking for the body part. And then the rest is pretty much the same. The rest is unchanged. So let's go ahead and run this query. Now, as you can imagine, this query is going to return a lot more data because every study has multiple series. For every one of those studies, we're going to now get 3 or 4 rows instead of just 1. So if I click go, as you can see right here, so there is one study right here with 2 rows. It's a mammogram study, and you can see the series description is explaining to me which of the series this one is. Same thing here. These are also digital mammograms. And you see the different series that are listed right here. All right. Now, I mentioned that SQL is also used for manipulating data. However, we are not actually going to cover that today because, frankly, that's dangerous. Database is storing data, but it doesn't actually have usually a lot of checks. So like if you're trying to write to a database, you're basically bypassing all the business logic that ensures that your data is coherent and the integrity is good. So it's a bad idea, especially on production systems. If you're really curious, you can look. I will provide a link to some tutorials online. So the vocabulary is insert for adding new rows, update for updating information in existing rows, and delete for deleting number of rows. However, also keep in mind that most likely your vendor, if they give you access to database, are only going to give you read-only access anyway. So there's a link there. This link is an excellent, easy to follow tutorial that you could try. And with that, just some practical examples. So sometimes the vendors are not forthcoming with SQL access. Sometimes you have to ask. So I highly encourage you to do it. Again, they're most likely going to give you read-only access. That's good. Most likely, when they give you access, they're going to provide you with some documentation that explains to you what the schema or the design looks like of the database, so you know where to find information. Which one is the table that stores patient information, and which one is the table that stores study information, and so on and so forth. If for whatever reason they don't, some of the tools you use or specialized tools can actually expose the database structure to you and actually even show you the relationship. So they'll show you, patient table links to the study table, which in turn links to the series table, and so on and so forth. You will want to get some clients to be able to connect to the database. There are some good examples over here. So cross-platform, meaning these are clients that work with pretty much any database engine out there. So there's one called Squirrel, dbeaver. if you prefer it, you can use a database specific one. So Microsoft makes one for their own database. Oracle makes one for their own database. Postgres has one. And this is everything I had to say today. So thank you, and I'll be happy to take questions in the live Q&A session, as well as during the office hours.